Which will be really exciting, but it's my absolute pleasure now to introduce our keynote lecture, which is from Professor Vladimir Hachinski, whom you heard speak in our last Vascular Neurodegeneration Symposium. I don't think Vladimir needs much in the way of introduction, but for those of you who are new to this game, he has really transformed the understanding, diagnosis, treatment and prevention of our two greatest threats to the brain, which are stroke and dementia. He co-discovered a link between Alzheimer's and stroke and introduced new concepts in a new clinical diagnosis tool. We say it's a new clinical diagnosis tool, but Vlad's got a standing joke about the Hachinski ischemic score in terms of how old it is. He also founded with John Norris the first successful stroke unit, and for those of you who aren't involved in acute stroke care, I just have to emphasise how incredibly transformative that's been for stroke unit care across the world. He was the editor-in-chief of Stroke and has published 18 books. He's received the Order of Ontario and inducted into the Order of Canada, so he's got multiple awards from his home country. He's been the president of the World Federation of Neurology. He's been awarded 4 honorary doctorates, and he's currently Professor of Neurology and Epidemiology and Distinguished University Professor at Western University. And he's going to talk to us about stroke and dementia prevention. What can we do now? Thanks, Vlad.
Thank you, Amy, for that nice introduction. There is a problem with that. The problem is, if I'm as good as an introduction, I've gained nothing. If my performance is anything less, you'll be disappointed. But despite the postprandial sopor and my circadian clock that tells me sometime after midnight, I hope I can live up to your nice introduction. I feel that I'm among family. I've been here last year. I know most of you, a good portion of you. And so what I'm going to say, it's in part to share some information, but also to provoke a bit of discussion, because I believe that we're ready to do more than we're doing. And I hope that you, well, either challenge what I'm saying so that I can respond better to whatever I'm saying, or change my mind. Either is fine. So even though I'm going to cover a very broad field, I'll try to use conventional headings, so at least you know that I have an order in which I'm doing this. So the first bit has to do with epidemiology. And it's the fact that if you look at DALY'S, disability adjusted years, which is an index of combined early mortality and years lived in disability, then in the whole world, the leading causes are nervous system causes, 10% of all the DALY'S. And then if you look at what are the leading neurological disorders, is actually stroke, 42%, and dementia. The good news is that they share the same risk factors. And we have good evidence we can prevent stroke, and I'll try to convince you that we have enough evidence to begin preventing some dementias. Now, there are many studies that look at dementia and stroke, or even report them together. But as far as I know, our group was the first one to look at them together and ask the question, do they interact? Or they pose, at least, do they pose risk for each other? And the graph that I'm showing you is based on the Canadian Study of Health and Aging that involved about 12,000 subjects, mostly live in the community. And what...
It's showing this one right now. So.
Yeah, well, that's fine. That's fine.
Back to this
that's fine, so you can sort of follow them.
Okay.
So, right. So there were some interesting facts. If somebody over the age of 65 had a stroke, then 64% have some cognitive impairment, which we heard earlier today. If, on the other hand, you ask the question, somebody who has some cognitive impairment, somewhere along the spectrum of cognitive impairment, then a quarter of them have had a stroke. So clearly, it doesn't show that they're interactive, but certainly it shows that they appear to represent risk of each other. If you have one, you're more likely to develop the other. And I think the interesting thing is that if you look at the red, then it tells you roughly 8% of the Canadian population of the age of 65 has had a stroke, about 8% are demented. So if you look at the pink column, then it tells you that for each person who's had a stroke or dementia, they have some cognitive impairment. So cognitive impairment is the common basis of the risk for stroke and dementia. They just happen at different stages to different degrees. Now, by now, I think it's pretty obvious that having a stroke doubles the risk of developing dementia. And I think this is based on 12 studies of incident stroke and involved 1.3 million participants. So I think that we can be fairly sure that this is a fact. Now, this is a list of the common risk factors, and you can read faster than I can talk. So I'll give you a few seconds to read the slide. This is not news to you, but the next slide might be. And what this shows you is that the traditional risk factors, particularly high blood pressure, are also risk factors for accelerating neurodegeneration. As you can see from each of those lines, which is each of them is a study, that having hypertension increases the deposition of amyloid. That hypertension also contributes to tau deposition. And people with high homocysteine level, when they die, often have greater tau deposition. So it also follows that if you treat the vascular risk factors, you're also perhaps slowing neurodegeneration. As you probably know, in principle, about 90% of all strokes are preventable. A new factor that we've become much more aware recently is that if you look globally now, that up to 1/3 of attributable risk of stroke is due to pollution, air pollution, outside pollution, and also indoor pollution. And last year, there was an article published from Canada, actually, that showed that it is a risk not only for stroke, but also for dementia. This slide shows you that the closer you live to a major highway, the more likely you are to develop dementia. Now, we know that New Delhi and Beijing are very polluted. But you also may know that the atmosphere is interconnected. And what happens in Beijing matters in Melbourne. So we have to become much more aware that some of these debates about global warming are also our affair, because they matter to our brains. Now, here is a new, old risk factor. We have known, at least I have known since medical school, that trauma to the brain predisposes you to dementia. And the most famous case is called dementia pugilistica. Boxers, particularly those who lose their bouts, are more likely to develop dementia. What is new is that even concussion that does not lead to loss of consciousness can double the likelihood of developing dementia. And in the past 3 years or so, it has been possible to image tau. And this happens to be from a person, a young man who suffered trauma. But as you know, increasingly, tau detection is also being used for studies of cognition and dementia. Now, let me talk a little bit about pathology. Last year, we published a systematic review of several well-conducted longitudinal studies that involve pathology. And what I showed was that about a quarter of elderly individuals have vascular pathology and no cognitive impairment. Another quarter have Alzheimer's pathology and no cognitive impairment. You put them together and it doubles the chances of developing dementia. Again, suggesting, but not proving, that they're interactive. Now, I want you to pay particular attention to the circle on the left. It turns out that half of the elderly are carrying pathology and they're cognitively intact. And this is the sunny side of cognitive impairment, that there are individuals who, despite the pathology, are cognitively normal. In other words, what are the factors that compensate against this pathology that they clearly have? And I don't think we've exploited enough this side of it. I think part of it we heard from Dr. Rolston, who's very interested in what happens after an injury. We have much more to learn to see whether, in fact, we can enhance the protective factors. We know them sociologically, like education, but I think they might be also biological ways in which we can enhance that resilience that is becoming into our awareness. I'm going to do a quiz here. What is the commonest outcome of cerebrovascular disease? And please don't be afraid to say it. What is the commonest outcome? Who's the most junior person here who can most easily be wrong and not feel embarrassed? Who is the most junior? All right. Okay. So what's the most common outcome of cerebrovascular disease? Stroke. No, that's wrong. Say, I put you up. I mean, but most of the audience is also wrong. They think it's stroke. It isn't. It isn't. It's vascular cognitive impairment. Now, let me explain. Huh? Yes. I'm sorry. So probably the first evidence for this came from the ROTTERDAM study. It was alluded to by Professor Sullivan this morning. And what they showed was that with increasing age, you have increasing likelihood of having a stroke. And if you follow the red bars, you can see the older you are, the more likely you are to have a stroke. But then look at the blue bars. Those are so-called silent infarcts. I think they're better described as asymptomatic ones. If you examine these patients, they in fact have subtle neurological signs. They have also cognitive deficits, particularly processing speed and working memory, the sort of thing that we heard from Jess. So, considering that most cerebrovascular disease is asymptomatic, however, a good subgroup of the symptomatic ones do have cognitive impairment. And you see, and we have a cultural bias towards detecting memory and very little, any sensitivity to detecting executive dysfunction. For example, 200 years ago, most people lived in the country. If they met a new person a week, they were doing well, and for sure they would remember them, right? Now, in this meeting alone, how many people will I meet? Probably 2 years from now, we'll be at some conference. You say, remember me? Well, yes. Well, we were at the, at the workshop, remember? Yeah, sure. All young people look alike, right? And then you'll say, well, the poor man is losing it. And if we had a conversation at the cocktail party, and I didn't know about Brexit or Trump, you would say, what? You don't know about that? So, not only are you supposed to keep up with the news, don't supposed to remember the people you are. This is totally unreasonable for memory. We're not designed to remember all these details. On the other hand, do you realize that every year there's more fraud of the elderly, perpetrated on the elderly, than the cost of all the recent wars that the United States have been involved in. In other words, Afghanistan, Iraq, etc. And the reason is that, that I strongly suspect that a number of individuals who, as they get older, are losing executive function, but it's not detected because even as a physician, you have overlearned what you need to do. So if you don't know, you know what to do. So you acquired very high skills, and unless you're doing research, which challenges all the time, you can be a perfectly competent physician. whose formal executive function, if tested, would not be that high. It's pattern recognition, it's all sorts of other things. And so I'm saying to you that probably usual, what's considered normal executive function in the elderly may not be, because so many elderly are carrying silent vascular disease. So keep that in mind. Conclusion, you heard it here first. The commonest outcomes of vascular disease is not stroke, it's cognitive impairment. Vascular cognitive impairment, to be precise. Now, I'm not going to say a lot about how we classify dementia, etc. Most of our definitions don't work. We're not good at detecting dementia, and most of the definitions that we have are not very precise. However, the good news is that we're able to identify pathology in vivo now increasingly. This is an example from a paper by Wardlow in which identifies the type of vascular lesion you can identify MRI quite precisely. Similarly, we can identify not only amyloid, but also activated microglia, in other words, inflammation. And I alluded to it in the question period, and this is the work of Alexander Thiel, who has shown that after a stroke, that the inflammation of the white matter, which is widespread, just like we heard this morning, correlates better with cognitive status at 6 months than does the initial cognitive status. So clearly, potentially, this is a target, because inflammation seems to be a common accompaniment of all types of cerebral lesions. And as you saw already, we can detect tau. So some time ago, I wrote an editorial for Brain, and I talked about the fact that we can move from muddled diagnosis, like mild cognitive impairment, which has become just a very confusing area, to treatable mechanisms. And in the future, I think what we should do is, first of all, define very precisely the type of patient that we're dealing with, and then try to identify and quantify the mechanisms that have led to the cognitive state. Now, if you're going to ask me, well, what shall we use? I just also wanted to mention that the basis of that study by Thiel came from a study that was done by Sean Whitehead, who was a PhD student supervised by David Chiquette and myself, who is now a colleague. And again, without going into the slide any details, I'll give you the bottom line. We used the model of Alzheimer's disease in the rat that overexpressed amyloid. And we found if you produce an infarct in the animal that has amyloid in the brain, then the infarct is larger. And instead of shrinking with time, it actually grows. And similarly, if you look at inflammation, then the inflammation is greater in the animals that have amyloid in the brain. And instead of settling down, it flares. And this correlated with histological findings and also behavior. So most elderly brains carry some Alzheimer's pathology. So all these assumptions we're making about lesions on the brain, you have to also add the fact that not all brains are alike. And in some of them, you may have an Alzheimer's substrate that actually multiplies the effect, whatever the ischemic lesion produces. Now, I have another question. What is the first thing that happens in what leads to what we call Alzheimer's disease of old age? And again, I want to make this interactive. Nobody really knows the answer, but let's have some opinions. What is the first thing that happens in the brain that eventually leads to what we call Alzheimer's disease of old age? The next most junior person. After you, who's next? Dr. Gottlieb, are you the most junior? I'll pick on you since I know you. Well, what's the thing that sort of starts the whole thing going? Inflammation. Well, listen, you could be right. I don't know. You could be right. Other opinions? Tau. Tau, yes. Certainly there's a whole school. The Taoist school. Dr. Ralston. Pardon?
A breakdown in microvascular flow.
Ah, right. Well, any others? Good, we're getting diversity here. Yeah?
Physical inactivity.
Which?
Physical inactivity.
Oh, no, I meant actually pathology, like what's happening in the brain. Tau deposition, amyloid deposition, inflammation, yeah, etc. Yeah, well, good. Well, all right, you heard about the ADNES study before. This is a study that selects individuals for the risk of developing Alzheimer's disease. And so there was a group in Montreal led by Alan Evans that by using sort of artificial intelligence and engineering equations, in other words, methodologies that make no assumptions about hypotheses, they asked the very question of these data. And the ADNES study is very thorough. They do everything on them. They do brain imaging, lumbar punctures, they do PET scanning, and a subgroup of them, so they're very well studied. Now, I don't expect you to interpret this, but I'm going to tell you that what they found was that the first step in what leads to Alzheimer's disease of old age is a vascular dysregulation. I repeat, vascular dysregulation. So we vascular people should be jumping up and down and celebrating, I told you so, right? Who agrees with me? Gee, you're not very enthusiastic, are you? Oh, thank you for agreeing. One person agrees with me. All right. Well, no, I don't think we should be jumping up and down. And I'll go, and the reason is the neurovascular unit that we also heard about. Now, embryologically, the neurons and the endothelial cells grow in tandem. And they feed each other growth factors. And so if one gets sick, the other one gets sick. If one dies, the other one dies. If Romeo dies, Juliet dies. So, in other words, you can have decreased blood flow, but you don't know whether it's decreased demand or it's ischemia. So you really could have the same results from a neuronal initiated problem as you could from a vascular initiated problem. So I believe that they're correct in the observation, and it happens exactly in the regions where it has been described as happening in so-called Alzheimer's disease, but we do not know yet to what extent is it one, the other, or both. And since they are interactive, almost certainly it's both. You cannot have a faulty vascular system without affecting neurons, and yet a COLA from New York has shown that if the neurons secrete beta amyloid, it paralyzes the capillaries. Again, not only producing ischemia, or at least decreased oxygenation, but also decreasing the clearance of beta amyloid, compounding the problem. Now, a word about terminology. By now, the evidence is overwhelming that the only types of pure Alzheimer pathology are those dominantly inherited ones, which is about 1%. So I've tried to convince the Alzheimer's Association of the United States to drop the term Alzheimer's disease. And they said, you must be joking. It's our brand. So I said, would you please at least talk about the Alzheimer's syndrome? Well, they're working on it, okay? But I think at least we can use it, at least to acknowledge the reality that it's really a spectrum. There isn't any one disease. And by the time they're elderly, they have multiple pathologies. And not only with the review I showed you, Schneider from Chicago showed that perhaps most convincingly in 2007 by doing very careful pathology. Now, how about vascular cardiac impairment? This is still an issue. I got a request from Era Kachaturian, the managing director of Alzheimer's disease and dementia, and he directed it to Deborah Gustafson, who's an epidemiologist from the United States, to Betsa Slokovich, who again is a scientist in the United States, to myself, and it says, "Can you give us a good? Can you give me the latest good reference on vascular disease?" So Debbie said, a tough one, but she didn't commit herself. And well, I'm not afraid to commit myself, that's why I have all these wounds. I said, well, there isn't one because there's no such thing as vascular disease except as an exception. That if, just like Alzheimer's disease, the only pure types of vascular disease are the inherited ones like CADASIL, or exceptionally, if you had rampant hypertension and multiple infarcts, you have multi-infarct state. But that's rare. What's common is having vascular disease. And it was John Boulder, who was a fellow of mine at the time, who's now a consultant in Britain, and I, who actually suggested the term. Would you believe in 1992, when I was a boy, right? I mean, it's taken that long, and now it's cut down. People use it, but they still think it's a real entity. What we meant by that is any cognitive impairment caused by or associated with vascular factors, with the idea that of all the pathology we know, the only one we can treat is really vascular. So the whole idea is that it's a spectrum, and it's trying to identify a mechanism, a treatable and preventable mechanism. So that's the definition. So I shouldn't have done what I did, because then Zavin Khachaturian said, well, would you write an editorial on that? Well, sure, foolishly I agreed, so I have another job on top of all the others. But I found it interesting that there's still confusion. And then Debbie again said, well, can we use the word disorders, like cerebrovascular disorders? And I said, no, because it implies they're vascular entities we can recognize and define. Well, we cannot, at least I cannot, unless it's CADASIL or a pure multi-infarct dementia because of, say, heart disease with valvular disorders. So we have a big job to do, because it's difficult for us not to have something that we define. But reality is more complex. And there is a way of defining reality without compromising the facts. And this is based on a workshop that Gabriel Leblanc and I organized for the NIH. And what we try to do is saying, okay, if you're going to describe cognitive impairment, be sure that you have some core elements. Age, sex, whatever else epidemiologically. Then if you're going to do imaging, at least have these things. If you're going to describe lumbar puncture, you have to have this. And the idea is that if you have well-defined data points, you can make up certain criteria, be provisional. And as you study these patients and have meaningful outcomes, like conversion to dementia, you can then correct whatever provisional criteria you have. And so eventually you develop things that are based on facts and not people getting into a room and inventing criteria. Now, I'm happy to say that since we published these harmonization criteria, standards, that there have been 28 studies around the world that found that useful. And again, you can select your own set of data points you consider important, but then give us the raw data so we can break down what you have studied and compare your patients with ours. Now, by now, the association of cardiovascular health and dementia is overwhelming. We heard some evidence this morning, and this is from a 3-city study in Britain, not in Britain, sorry, France. And it actually, what they did was, it took the American Heart Association has 7 risk factors that put you in danger of developing vascular disease. And they found, to put it negatively, for each of the risk factors that was missing, your chances of developing dementia would decrease by 10%. So the association is really very strong. And based on and so the association has been around for a long time. And I want to go now into the fact that I shared with you already, and that is that a stroke doubles the chance of dementia. In the year 2000, a number of us persuaded the Ontario government, which is the largest province in Canada, 14 million, that they should invest in stroke, in a stroke strategy, building more stroke units, stroke prevention clinics, public campaigns on risk factor control. And we knew that the outcomes after stroke were better. So we asked the question, what has happened to stroke in Ontario over a 12-year period? The answer is in the bottom red line, and that is that it has decreased by 32%, and dementia by 7%. Now, we have a natural experiment going in Canada in that half the provinces have a stroke strategy and half don't. So now we're looking to see whether what we found in Ontario is also true in the other provinces. You are no doubt aware that there was a study called FINGER, in which Miyake Vipelto randomized individuals at risk of developing dementia into what we call usual care, which give good advice, or intensive care, have programs of physical activity, mental stimulation, social interaction. And she found that that both groups increased their cognitive capacity, but the intensive care significantly more. And now there'll be finger-like studies in at least 4 places I know of, in Europe, in Canada, in the United States, and I believe Singapore. So now they're calling them, by the time they have 5 studies, they'll call them the hand studies, 5. All right, and then you perhaps have not seen a study that was published in 2017. This is from a stroke, atrial fibrillation registry. And even in Sweden, only half the people who should be anticoagulated with atrial fibrillation are. So they're able to do a propensity score. In other words, match very closely people who were anticoagulated or not. And they found that the people who were anticoagulated had a 48% reduction in the risk of developing dementia. Go figure. Now, we know from other literature that even if you account for clinical and silent strokes, there still is an association of atrial fibrillation with cognitive impairment. And we have a hypothesis that we're going to test, and that is that one of the mechanisms is that a number of elderly patients have leaky blood-brain barriers, and things like fibrinogen that ordinarily don't get into the brain, and they're very toxic, particularly to white matter. And so we're postulating that the people who were anticoagulated had their levels of fibrinogen or their products knocked down, and therefore had less likelihood of having fibrinogen or its products penetrate the brain, cause damage to the white matter, produce mainly executive dysfunction. And so what we're going to do is to take advantage of the fact that in the Gothenburg study, this is a longitudinal study directed by Ingvar Skog, they have saved plasma and they have saved CSF, frozen plasma. So they are gathering all the information about brain imaging and everything else. And so we have a grant in preparation, so we're just asking money to do fibrinogen levels in the CSF and in the blood. And if we are right, then it means that anticoagulants could become a new treatment for the prevention of risk factor of dementia in individuals with a leaky blood-brain barrier. And then there had been a study published recently in JAMA, the Journal of American Medical Association, in which they had studied about 9,000 individuals who were at risk of developing vascular disease, and they stopped the study early because the outcomes were better in the individuals who had targeted blood pressure of 120 as opposed to 140. And there was a subgroup study called the MIND brain study, in which they also did cognition and brain imaging. And the results were that the primary outcome, in other words, a reduction in dementia, did not reach significance. However, the subgroup of mild cognitive impairment showed a decrease of 17% in the risk of dementia. So, of course, the immediate conclusion would be, well, target the blood pressure 120. I would say not so fast. And the reason I say that is, one, is that we may be causing hypotension and subtle ischemia in the deep white matter of the brain. And of course, we have no way of detecting that. So I'd be cautious about that. I think I'd like to have more evidence before I target at least elderly patient to 120. It might well be that the blood pressure for the brain needs to be lower, but I don't think we know what that is. And there's also a theoretical reason, and I think, and this is from a study by Yarikola, published late last year. And what they did was to knock in ApoE4 allele mice compared to ApoE3, which is the usual allele. What they found is that the individuals with the ApoE4 had had a less richness of the capillary bed as compared to the ApoE3. And also that the cerebral blood flow was lower in the ApoE4. Now, isn't it interesting that ApoE4, a classical risk factor for Alzheimer's disease, has at least one vascular mechanism? Again, speaks to the fact that they're closely interrelated, neurodegeneration and vascular disease. And what really interesting is that if he produced hypotension, then some of these mice developed damage to the white matter, particularly corpus callosum, and also had decreased cognitive function. So you can see why I'm cautious, because we don't test for ApoE4 in most of our patients. And if they're ApoE4, we may be doing a lot of damage without realizing it. Finally, let me come so what do we do? Well, scientifically we carry on with sort of more information. But I think we also need to be aware that we have to act at a greater level, in other words, at the policy level, and perhaps in organizations that deal with stroke and dementia. In 2006, there was a stroke day that was launched, and in certain parts of the world it was highly successful. This is a picture of the final soccer game in Brazil. And in intermission, the teams of both teams came out wearing T-shirts and something that says that 90% of strokes are preventable. So based on some of the evidence I shared with you, the proclamation that was initially proclaimed in 2006 was updated to include potentially preventable dementias. And the good news is that all the major organizations dealing with the brain have endorsed it, like the World Federation of Neurology, the American Heart and Stroke Association, Alzheimer International, etc. So there is a movement afoot to join forces to begin preventing both major threats to the brain together. And last October, there was a meeting in Berlin it's called the World Health Summit. And it's special because it's addressed specifically to policymakers and also to industry. The WHO is not allowed to invite industry because somehow they will contaminate them. This forum, on the other hand, is specifically addressed to people who have the money to do something about it, including entrepreneurs who want to invest in medicine. So we had a session, and the theme was dementia prevention by stroke prevention. And there'll be a Berlin manifesto based on this, where all the scientific evidence for beginning to prevent both together will appear. And if you want to have sort of the practical things of what to do, then I think most libraries carry the Cambridge. I mean, Cambridge has, nowadays nobody buys books, and I would expect you to buy books. But I think most university libraries subscribe to, say, Cambridge publications. And so if you wish, you probably will have one at your library, and you probably can access it. And this is a multi-authored textbook, but it's really aimed at intelligent lay people. By this I mean, basic scientists, non-specialists, and even some of the specialists could find it interesting. But I think the important point is it brings into two covers what we know that we can apply now. And then prevention has been based on preaching, and preaching doesn't work. So information is important, but also motivation and implementation. And so we need to aim not only at preventing disease, but really fostering brain health. And a number of years ago, when I was president of the World Federation of Neurology, we formed an alliance of all the major brain organizations to try to influence the United Nations in their non-communicable diseases proclamation. And so these are the premises that we based it on. Now, this idea of brain health hasn't taken hold in North America, but it has in Europe. And Norway is the first country in the world to actually have a national brain health plan. And in June of this year, there'll be a symposium in Oslo that'll be with the participation of Monica De Luca, who's the president of the European Brain Council, with Kurt Høie, who is the Minister of Health in Norway, with Anne Hege Ormond, who's the president of the Norwegian Neurological Society, and myself on the topic of developing brain health plans for Europe. I hope that becomes an example for the rest of the world. So, to conclude, neurological disorders represent the leading causes of DALY'S. More than half are due to stroke and dementia, which are preventable to different degrees. And we need to work together where we can, differ where we must, in the common aim of preventing both stroke and dementia, beginning now. Thank you.
So thank you so much, Professor Hachinski. That's extraordinary. We do have time for about 5 minutes of questions before the next break, 5 to 10. So, oh yes. So stay here. Can't sit down yet. Does anyone have any questions to kick off? Professor Bush.
Thank you for a wonderful presentation. I was intrigued to hear about fibrinogen. Your comments that it was. Did you suggest that fibrinogen in the brain is a biomarker for vascular leakage and that fibrinogen should never be found in the CSF? The reason I'm asking is because we're studying CSF components and we do see fibrinogen in people who are meant to be healthy.
I'm not a fibrinogen expert, but we have co-opted somebody who knows much more about it. It was Gregory Del Zoppo, who is actually is a practicing hematology, who is a leading neuroscientist. He's one of the people who contributed to the idea of neurovascular dementia. As far as I'm aware, there shouldn't be any fibrinogen in the CSF in normal circumstances. Nobody's going to challenge you? Oh, yeah. Oh, good. Oh, John. Rory.
Dr. Malroy.
He and I met at Queen Square in London, a few years ago, maybe 10 or 15. Don't tell!
Yes, a question and a play. A question is that intriguing finding that the relationship between air pollution and stroke and dementia. And now I don't expect you to go into details about that, but what would you put your money on as the cause of that? Because particles themselves have been around for a long time, but they're now being coated with all sorts of benzene and other toxic molecules. And secondly, a plea that whether we could possibly have these symposia in such a way that we don't have to fly everywhere. Because flying is the elephant in the room when it comes to pollution.
Yeah. Sorry, what's the question?
The first question was talking about. Could you just repeat the first?
The first question was, I have always been intrigued between the relationship between pollution, stroke, and dementia, and I just wondered what aspect of pollution you thought was this? Was this a social phenomenon or a biochemical phenomenon, or?
Oh, I think there's good evidence that the nanoparticles penetrate the brain and the vessels, so you have inflammation in all the organs. So inflammation is a major component. There might be others.
Yes, I just wondered whether the particles were coated with different sort of molecules that would cause an increase later.
Yeah, apparently the pathology also varies according to the size of the particles, the whole literature on that. It first was shown on the lungs, which is the most obvious. Then it was shown in the coronaries, then in stroke, and now in dementia. So it involves the whole body.
I should note that this is from John, who's probably planted more than 200,000 trees now, John?
No, the other thing was just a plea to if we could reduce our pollution, we have to reduce our flying.
Yes, I agree.
And we've got the technology actually to have these symposia from our lounge rooms.
Tony?
So one prediction from what you're talking about would be that genome-wide association studies, so GWAS for Alzheimer's and other common dementia, but Alzheimer's is probably the only well-powered one, would give you gene candidates that point towards the vascular pathology as a proximal cause. And I guess it's starting to point towards microglia and inflammation, but do you see the genetics as supporting this?
I think we have to do much more in genetics, because we have concentrated on so-called Alzheimer's disease, and the studies have been selected. So I think if we're going to have genetics contribute, we have to study whole populations and look at everything that we can look at. Because I think apart from APOE4, all the other genes that they identify have small effects, and they're interactive. So I think we have a long way to go. And the other point is that I think, medicine has advanced by a reductionist approach. We control for everything and have a little piece. But knowledge accrues in pieces, but it understood in patterns. And there's a whole literature of complex systems that we should avail ourselves in. And now in the big data age, we can begin doing what they do for weather prediction. If you think about it, they do pretty well. They're wrong sometimes, but it's a very complex dynamic system, and there's no reason why, if we have the data, we shouldn't begin to looking at some of these interactions.
If I could just make a comment on that as well, Tony, I think it's a really good question, and I'd have to say that at an AAIC, the Alzheimer's big meeting once a year in, was it the year before last, it was on GWAS, it was a geneticist, and the things that came out with all of the genes were associated either with vascular health or in fact with neuroinflammation, the new genes. And the other thing that came out was the non-Alzheimer's effect of APOE4. In fact, there were a number of plenaries on the fact that it's really important in mediating neurovascular coupling and vascular regulation, or dysregulation, if you like. So it came out, as I think Sheila said, that APOE always swamps the GWAS because it's such a strong effect. But it looks like APOE probably is very important for vascular health, and the new genes look like that at least half of them are implicated as well. Any more questions? No, I think we're ready for our next cup of tea and then the last session for the afternoon. So yes, we're having a break, so we kept you starving and now we're going to keep you hydrated.